Recording is on.
Mm, is my screen visible?
Not yet.
Oh, not yet.
Not yet.
Window and it should be now. Right.
Yes, yes.
Okay, today last time we did something multi-threading. So this time we will start with futures, async coding. So first, basic syntax to write async code is we just make function async, and it actually means that okay. So like let's some uh, okay now we can start like this. So both function A and function B both are synchronous. And when I try to call this A and B from main function, it is I just do A and B. Now, but it means that function A has to be called. We wait for the result, and then again same happens for B. But what I want to do is that I want to wake up the cursor here after the function A has ended. So we try to make it async. So it is like let t equals to a1, let b. So what happens here is that when I start like this, this line is executed. This line is also executed, but function A is yet not started. To start function A, we just have to do something called await. Okay, now how it works. Now first this function will execute and cursor will wait again, and then we'll start with b1 dot await. Now this b function will execute. In simple terms, uh, a uh, b, and to call await is only written in a async function, so this needs to be async. But to run async function we need a runtime. Generally we all use Tokyo, so I'll also use that Tokyo. Okay, see, now we might sometimes we get confused that uh, until this okay, uh, okay. Mm, okay, can anyone tell me the output of this code? What happens actually? uh, we have two cases like this, like we execute function A. As soon as function A is executed, we also start executing function B. So A and B print almost at the same time, or we wait for function A to complete and then we print function, then we execute function B. So there are two cases that we can think of. Both occur concurrently means at the same time, or first function A is completed and then function B. So anyone can, Arka, can you tell what will happen?
I, yes, the first option which you gave here,
Huh.
both occurs concurrently. I believe in this particular case that will happen.
Okay, and Andrew, what do you think there?
I think that both will run concurrently.
Oh, this doesn't happen. Uh,
So I mean that
wait, wait,
they
wait.
should print first.
I think I made some mistake. They generally wait, but why is something is wrong? Wait.
It's weird that B it's printed before A. It printed before B.
Oh, oh, okay, okay. Yeah, you see, uh, okay, I think I made some mistake. Okay, generally what it is happening like that. First function A is executed, then function B is executed. Both function does not happen concurrently. There was some, wait, yeah, I wrote this. You chose this answer. This is incorrect. uh, yeah, logically you're right that both will print simultaneously, but reasoning for that is that first we wait for 1 second for, then we print A, and then suddenly we print B, then we wait for 1 second. So if I do it like this, sorry for confusion.
No, but if you put the sleep in the A before the print,
Yeah,
it's not very clear because I expected that
yeah, yeah.
when you call the function B, the code will start to run. Actually,
Okay, you thought that first function A will execute and then function B, or simultaneously. Okay, okay, let me repeat. And you thought that both will execute simultaneously or concurrently, sequentially.
yeah, I imagine that somehow they are started on different threads.
Okay, so this thing doesn't happen. We can check using a simple printing statement. First, function A is executed, and then we wait for A for 10 seconds, and then we start with function B. So, a simple assumption that I also had in starting that await makes all these function happen concurrently, but this doesn't happen. So it is like we wait for A1 to complete, then we wait for B1 to complete. So then now we have two kinds of problem here. See, if both starts at the same time, we do not know when these end. Uh, Sometimes either A can end before or B can end before. So this makes this code uh, non-deterministic. Okay, so there is a way. So generally, so to make it easy for us to understand, whenever we do await, this is called, and then whenever do await, then this is called. Okay, so how do we make them run concurrently? So we do have a macro for that. This
So
is
I have a question here. So when you call the function A on line 20,
Okay,
So nothing from the function is starting to execute like from a normal function.
no, we do not have this. When we do, what happens that this async function returns something like implement future.
Uh-huh.
This return
Okay.
something like that. Okay, it is. I cannot execute something like that. So at this time, the function a is not started executing. It only starts when we call await on the future. So I hope that makes sense. Yeah, this is the fact. Not nothing is logical here, but
If you make a function C which is not async and you call it
okay. Function C. Okay.
uh, and which prints C and you call it before a1 dot await,
Uh, okay. Await will not. Okay. I let's do. Uh, you want me to call this function before
after B,
uh,
after B.
here?
No, no, before a1 dot
Okay.
await. There.
So I think it should print C, A, and B. Let me reduce timing. See, C A C
Thank
B.
you.
Okay, so we have completed first milestone to understand that uh, multiple awaits in a function does not make the code concurrent or fast. It is just sequential. So okay, now we can choose to have a single thread or multiple threads. To do so, we just use something called flavor equals to current thread. This is for single thread, and we have multi-thread, and we just mention how many number of threads I want. Even in both the cases, the logical functioning of the execution of the code remains the same. So we might be wondering, how do we execute multiple features at the same time? For that, we have two kind of macros. One is join and one is select. So uh, wait, let's do something. Hold.
Don't you need the Tokyo
Now
annotation in the
we
function?
have already imported that.
But on the main, don't you need the
Yeah,
Tokyo
yeah.
annotation?
Sorry for that. Hmm. It did not execute simultaneously. Uh, wait, something is. Oh, I'll cover it after some time. I think I made some mistake. So generally to uh, execute task, we have select and join. Uh, Join is used to execute all tasks at the same time, and select. Uh, so join and we have basic difference between select and join is that select only waits for one task to complete, and join wait for all tasks to complete. So I'll share the code of implementation after some time. So uh, okay, so this is we have a basic of async coding. Now we can I'll share something called how to write a custom feature also. uh, do you know the meaning of polling in this async coding? Anyone?
I mean, constantly getting the, you know, value of, I mean, waiting for a value to get executed. I mean, the process is happening and something is, we are calling back to back that,
Yeah,
when it will happen.
like I have a custom feature with myself, okay, and it has some value, right? And I implement feature on this thing, right? So we have output type to be I redo, and we have a poll function because this feature create implements this poll function. We have self pin uh, at mute self, and we have a context at mute context. Okay, so future is being polled, and we have okay. Now we have a future. We can create a future like my future, and then we can have value of 4. Now to call this to execute this feature, we have to do something called await, uh, and whatever result I get will be stored in this result variable. Anything. So few dot await. Okay. You see, uh, we can create a custom feature like this, and then we can just get the value. So we have two types of result type. One is poll dot ready when our function is ready, and we have something called poll uh, pending. It means that our future is yet not ready to proceed further. So we can do something like if self dot value is a even number, then we will just return pending. Else we will, if it is odd, then it means it is ready. So self dot value, I think this should work. Let's see. Okay, okay. So you can see this is loading infinitely because our future is yet not completed, so it is pending. So Arka, do you know how to complete this future? Hello.
No, yeah. So I mean, somehow I mean, the value we are adding here is plus one.
Hmm.
But is it? I mean, somehow the value present in the future that needs to get updated. I'm
So
not sure how.
we did update the value.
We did update the value, but
Uh, can we do
somehow.
something like that? Let r2 equals to few dot await again. I think it should work.
Okay.
I think it should work. No. Okay. It is like we have to poll the function. No, this thing doesn't work.
So it is not polling automatically.
No. Okay, okay. I did not write that thing. W- Wait. Okay. We can poll this like this using context.
Okay.
So this will again poll the function.
Okay.
Yeah. Uh, so what happens is that in this we have a context, and in that we have a vehicle, and we wake by reference. So whenever we wake this thing, it means that we are telling the Tokyo runtime to please again poll the function.
Okay. Okay.
Okay.
I mean, some kind of loop was required.
Yeah.
Uh,
So it was my mistake, sorry. So so this is a very simple example. We can have complex logic here, but whenever our code needs to be called again, polled again, we just write cx waker and wake by reference.
uh,
Okay.
Shivang, just one question here. I
Okay.
mean, the custom future which you wrote, the value is a numeric value, value 4.
Okay.
I mean, this is a simple example, but ideally in real life applications, here we can put any expensive, let's say, function or something which can be, called as per required. These kind of things we can put it here, right?
Yeah.
I mean, ideally that should be the
Yeah, yeah, that
use
should be the
case.
case. Or we can create timer future also. Like we have a timer future. I'm just giving an example,
Mm-hmm.
and we can have the instant, uh, and it shall be the instant type, and we can initialize this timer future like this, and then we can just do function new and current time and expiry.
Okay, okay, okay.
Okay, then we can just await, and we'll just do like we'll ask what is the current time. Let cur equals to instant dot now if self dot instant is less than cur plus expiry is less than cur, then it means our timer has already expired, so we'll
Mhm.
just do poll ready. else
Yes, yes.
else we will update the current thing, we need to make instant equals to cur, and then we will just again wait for some time, and then we can just do cx dot vehicle dot awake. So it will call this infinitely, and we can have a custom timer future like this.
Uh-huh.
So
Got your point.
I hope that makes sense. So I think
Hmm.
generally we don't write, we I have not written or seen somewhere that we write code like this, but it should be known to have better understanding of how how future works. So generally what happens is that whenever we write a function like let me show you something. I was saying something, uh, yeah, yeah. Now one more thing that you must have, you must be seeing here is pin. So does anyone know
Yes.
the meaning of pin,
A
Andy?
pin is something. Sorry. A pin is something where that the memory location of that data is fixed. It will not move.
Yeah.
So we are kind of pinning that on that particular memory location.
So I'll put something else more into this. This is correct. Why do we need to pin in this async thing? Why future? Why do we not pin? Why do we not need a pin in simple function calls? Do you have any idea for that?
No, that I don't know.
Okay. So generally, what happens is that, like for example, we have a function, async function, right? Like this. Now we have a reference. We have a data in this async function, and we have reference to this data, right? So when
Yes.
compiler start executing, it will convert this function into something like this. Okay, and then
Okay.
and then this future is implemented on top of this thing. So it is same as my timer future, but this is converted into this and then this. Now you see,
Hmm.
we have a reference to some data, and the runtime is Tokyo. So you do not know what is happening in Tokyo. Tokyo just moves your data from one thread to another thread, right? And
Yes.
but reference is but reference keeps pointing to the data that was initially in this data, right?
Yes.
So even if the data if this future is moved somewhere, like let t equals to future, something like this, in behind the scenes,
Hmm.
right? And then we just do a equals to t. Now you see we have moved t. So
Yes.
so then data will also be moved. If data moves, then the reference value will keep on pointing to the previous location, but
Hmm.
that becomes invalid. So for that reason, we generally see that sometimes features are self-referential. It means it points to something that it contains, and to prevent moving of the data we use pin. So that is why we have pin in this poll function.
Okay.
Okay, same thing, we have box pin. Both are same almost. Box is like we have box is used for heap memory, and we pin that.
Hmm.
uh,
When the value is unknown to us.
yeah, and it can move anywhere, so you just fix that. Okay, so uh,
Okay.
this is the basic of I think we have covered sequential thing and concurrent. Okay, I'll share the notes with you. I have written some notes.
Okay.
Let's see what happens here. Okay, Okay, so we can use join and select to execute tasks concurrently. So what we have covered today is simple. Are await and async code completely sequential or concurrent? They are sequential by default. We can have
Hmm.
custom future by implementing future trait on top of any struct. We have learned about what are pending, how to use wake and a wake by reference. We can have multi-thread environment and a single thread on Tokyo runtime. And this is the way we make our code completely concurrent or concurrent. Select means that we only wait for one task to complete, and join means that we wait for all the tasks to complete. Okay,
Okay.
uh, and we use why do we use pin? And okay, now one more thing to keep in mind, like sometimes while coding we have function a, and we need to execute something like a async function here, right? So like we have async function task one. Now task one need to be executed, but to execute that we need to use await. But to use await, we need this a function to be async,
Yes.
and the condition is that we cannot make this function async because sometimes it is required. Like we have some traits that strictly needs our function, the function to be simple function. So how do we execute this thing in this in this simple function? We just create a runtime. Okay, I'll show how do we do that. uh, uh, we just do let we get a runtime. Okay, and then we do let result equals to rt dot block on, and then we just do our task one execution here like this.
Okay.
Okay, then we print a result. So I think we have covered almost everything around async. We have discussed about multi-threading in the last lecture. So any doubt, anyone?
Uh, just one thing, I mean, just curious to know,
Okay.
the first example which you showed, right? A and B, the first, initial example, async A and B, you
O-
know,
okay.
if you can.
Yeah. Here.
Yeah. Yeah. So if let's say mm, A1, I mean, for, we are calling A1 first, then I mean A1 dot await and B1 dot await should be, later on in order to execute the functions. If we flip the sequence, let's say B1 dot await first, then A1 dot await, then it will be CBA, right?
Yeah. You can confirm
Okay.
that. See.
Uh-huh. Okay.
Yeah.
I mean, it depends on.
Yeah. In simple terms, we call these functions lazy. We we call this function when
Okay.
required. So I'm not using too much of technical terms, but the basic concept is this: we only execute future using await. These are sequential by nature. This does not make your code very fast. It is same as simple function. We can have concurrency using uh, select and join. We need to understand the concept of pinning and other things. Anything else, Andre?
Yes, can you show again how you run A1 and B1 in parallel here?
Okay, we can wait 2 minutes. and this. Okay, see, when I use select, right? So what happened that it only waits for a single task to complete itself. Last time it was B, now this time it is executing A, and it is not concerned about other function. So again, let's try. This is A will print and B will not print. So, but if you want to do something called, if you want to execute all, we can just do Tokyo join A and B. Hmm, wait, okay, okay. We need to use another. It is Tokyo sleep. My bad. Sorry. See, now we can call these both function concurrently. Last time what was happening was that we were blocking the main thread. Now we can try for both. Let's see
Can you
what.
also print
Yeah,
thread
yeah,
ID in
yeah,
in each of the functions?
yeah. Let's see. I hope this should work. Mm,
And after the sleep, they are on the same thread.
yeah.
If you put the thread ID
Oh,
after the sleep, is it still the same thread?
we can confirm that. It should be on Threem's thread, but
And if you
Just do a
modify
okay.
the annotation on the main to have multiple threads, will it run on different threads, the functions? You showed earlier
Yeah,
that you
let's
can use multiple
let's
threads.
check. I'm not sure about that, but we can check. Mm, no, they're on single thread. Okay, let's see why is it not using. Okay, so to have something multi-threading, we have to do spawning. See, same. Okay, let's see one more thing. If I do by default, it should be multi-threaded. Okay, multi-threaded. And if I want to make this single thread, we have to use something current flavor. See, I hope this makes sense.
Yes, thank you.
Oh, okay. Anything else I can help you with, Arka?
No, nothing as of now.
Okay.
Uh,
Are you clear with this multi-threading and current thread using in Tokyo?
yeah, this one. Yeah, I got the idea of it.
Okay. So, Radu, anything I can help with?
No, no, for now.
So can we drop now? If not,
Just one thing to ask. I mean, when this video will be on YouTube, when it will be getting shared. I will be kind of revising it, so just for reference purpose.
okay. So I'll upload it tonight if
Okay, fine.
we are able to record this properly. I hope this gets
Huh.
recorded.
Okay, okay, sure, sure. Yeah, that's
And
okay.
anyways, I will
That's
be sharing notes with you. I did have created
uh
a simple PDF. Uh, I hope that might help any.
okay, okay.
Okay.
That will be also great.
Okay. So we can call off the call today.
Thank you.
Uh,
Then,
okay.
Thank you. Have a nice
Thank you.
day.
Thanks.
thank you.
Bye.
Bye.
Bye.